Yes, we are here to present project vehicle type classification system using convolutional neural networks with a Streamlit with web interfaces. We are now discussing about project structure. In this, we have three files: app.py, train.py, util.py. After the generation of training, model.sp will get, and then label.json. And we next in data folder. In this folder, have two folders: train test. In this train and test, have five classes. That is ambulance, bus, car, motor, cycle. Ambulance have around 1,100 images. Car have 2,000 images. Truck have 1,000 images. Bike have 1,000 images. Buses 1,100 images. And then we are splitting and using 70% for training, 10% for validation, 20% for training. And then we discuss about features. Have 5 features: CNN model, data augmentation, Stream.ai, training visualization, and have very flexible classes.
Let me explain the visualization part of our project. This is the live demo. And first of all, we have browsing files. For our convenience, we have taken real-time images where people are behind or above, before the image, actual vehicles. And first of all, I'm importing a screenshot. So here we have results. We have mentioned that the vehicle and the confidence level and decision is based on the given scenario. Around ahead of 85%, we have a high confidence. Before 85%, we have to review. So like that. And we have included a much number of members here, and so that the probability is class probability is lesser. So vehicle is motorcycle and confidence level is 56 here, and decision is uncertain. And for this, we have to predict car. The confidence level is 95.49, and let's choose for a truck. So this is what the confidence level is, and the decision is high confidence here. And for the bus, we have included the government bus of Tamil Nadu, and we have a vehicle as bus, and confidence is 97.59. Train.py, we have import statements here and a basic function which have base model as a variable, importing MobileNet version 2, which is already a pre-trained model in CNN. And by the use of MobileNet version 2, we have layers here, and each layers having global average pooling, which reduce the dimension into 2D, and dropout prevents the overfitting, and dense creates a learning patterns, and batch normalization stabilizes the data, and softmax creates the output probabilities. And for the get data generators, we have trained data generators here, which creates the augmentation of data. And for test generator, we have a test data set here. It imports by rescaling it. And we have created individually a trained generator, validation generator, and test generator here. And for evaluation model, we have used predictions for a model prediction, and classes for classification report and confusion matrix. For save class label, after creating the classes, we have to save in label.json, which is based on labeling the data. And for main function, we have using image size and epoch. Epoch improves the iteration. For every iteration, we have improving the test accuracy and train accuracy. And we have here if-else statement because of presence of train directory and test directory. Train have the callbacks here. And for the training model, we have history to create visualization in the stream, which is training history, which predicts the high model accuracy and model loss here. That's it.
This file mainly contains utility functions for image pre-processing, dataset handling, and visualization. The pre-processed image function prepares images by converting them into RGB, resizing it into 224 pixels, normalizing pixel values, and adding a batch dimension for model input. The load and pre-processing image function combines loading and pre-processing in one step. For visualization, plot training history shows accuracy and loss graphs, dataset relation functions, and get image statistics, and etc. Finally, create sample data structure, organizes folders, and validates structures, ensures the dataset is properly structured.
Project vehicle type classification system is built using Streamlit and a trained TensorFlow CNN model. The train.py file generates model.sp and label.json file. In the load model method, if the model.sp exists, then it is fed to the class model. Load labels. If the label.json file does not exist, it produces a warning to the user. Then we have the get decision result. In the get decision result method, we have confidence decimal, which produces a confidence score. The confidence score is based on if the confidence score is greater than 85%, then it is in higher confidence. If it is between 85% to 65%, then it needs review. If the confidence level is below 65%, then it is uncertain. Then we have a main method. In the main method, we have a upload file object. In the upload file object, we have a processed image object. In which we have a preprocessed image method, which preprocess the image and standardize and normalize the image by making it as 224 cross 224 pixels. Prediction in the prediction, our image is fed to the model. Then the model classifies the image on which class it comes under. The argmax decision colors. If we have a higher confidence, we have a green color. If the confidence is higher in emergency, then it is in red color. If the confidence needs to view, then it is orange. If it is uncertain, it is gray.